Guys, so welcome to the new video. In this video we'll be talking about this is the part 2 video of the iterations chapter, where we'll be focusing and talking more on graph sketching. So graph sketching is, in fact, we can say sometimes the trickiest, I mean not trickiest, sometimes you just need to memorize some of the graphs in here, and once you memorize the graphs, the questions will actually be very easy. So okay, let's just get into the video. So mainly in graph sketching, the topic of graph sketching, you're just going to have to know some basic graph shapes. Okay, some basic graph shapes where they can actually ask you in some questions. So, after going through some of the graphs, I will definitely try to attempt some questioning with you guys so you guys can have a better understanding on it. Okay? All right, so let's start looking at our graphs. So some of the few main graphs that they could actually ask you in CIE questions are definitely the basic trigonometric functions, where first of all you have sine x, cos of x, and tangent of x. However, they also do ask, and it's actually quite frequent, for the inverse. I mean, not the inverse, the asymptote of these graphs. For example, they ask for cosecant graphs, which is the 1 over sine x, and over here they ask the secant graphs, 1 over cos x, and they also ask cotangent graphs, which is 1 over tan x. So the reason why I didn't draw these graphs separately are because I want to show you how you don't have to really memorize these graphs. All you have to do is just map from the sine x to the cos x, or the cos x to the secant x, or the tangent x to the cotangent x. Okay, so that makes it much more easier and less of a burden for you guys. Okay, so first of all, let's start with the sine graph. So the sine graph is basic sinusoidal graph where it has two bumps, up here and down here. It intersects at pi and 2 pi, okay, where this would be maximum would be pi over 2, and over here would be 3 over 2 pi, which is 270 degrees. So this is the basic sine x graph, okay? And next we have our cosecant graph, where it comes in, dips at a maximum point, and comes back up. These are just the general shapes, okay? And we have the tangent x, where it starts, let me just label it 0, 0, and 0, where it starts at 0 all the way to 90 degrees, or pi over 2, where it's infinity, and then it starts again to pi, intersects at pi, all the way to 270, where it's infinity again, and then it finally comes back and intersects at 2 pi. Okay, so I hope you guys actually have a good grasp on these basic graphs. Okay, so I'm just going to now teach you how you can use this graph to transform to the cosecant graph, secant graph, and the cotangent graph. Okay, so first of all, I want you to imagine, okay, maybe not imagine, but make this simple rule for you, where you're going to reflect about the maximum points, we could say. And what I mean by this is, okay, let's have a look at our sine x graph. So why don't you maybe pause the video and try to point out where the maximum points are. Well, if you did find it correctly, it should be here and here. And the next step, all you have to do is basically draw yourself maybe a mirror across these two lines, across these 2 points. And what you're going to do is you're just going to reflect about those lines, where, so since our graph here is like this, okay, we're just going to take the segment before it intersects the x-axis. I mean, until the point it intersects the x-axis. So for this maximum point, we're just going to reflect it, where you get a graph like this, and down here you're going to reflect it like this, so you're going to get a graph like this. Sorry, my drawing's not good enough, but this is roughly what it is. So to actually draw it out, our graph would be like this. Okay? So this is our cosecant graph. That's it. That's our cosecant graph. Okay? So all you have to do, just find the maximum points and just reflect about it. Okay? So that's easy for sine x, where we get cosecant x. So I'm just going to label this cosecant x. Okay, and next we have our cos graph, where we want to, map it to our secant x graph. So like I said, find the maximum points with, find the maximum points where we have here, here, and here. And what we're going to do is we're kind of going to reflect about them. Okay, we're just going to reflect about them. And remember, take it up until the where the graph intersects the x-axis. Okay, so let's say for our first segment, we get this first maximum point. We're going to take it up all until it intersects the x-axis, and we're just going to reflect this. We're just going to draw it up. So we're just going to draw it up this way, and that's our reflection. Okay. And if I'm not mistaken, this should actually be pi over 2, just for reference. Okay, so I'm just gonna double check that with you. Yes, so pi over 2, and this should be 3 pi over 2. Okay, so now our next point is here, this point here. And what we're gonna do is we're gonna want to reflect about it. So what we can do is, just take it here and just reflect about it. I mean, it's just like, the bump, this entire bump from this x-axis intercept to here, we're just going to reflect that thing. Okay? And now, the next maximum point here, we're just going to do the same thing as we did for the first one. And we're just going to reflect it from here all the way here. So we should be getting something like, forgive my drawing please, we should be getting something like this. Okay, so that's your entire, secant graph. I'm sorry if my drawing isn't that accurate, but you should get something like this. Okay, in most CIE questions, they don't really expect a very accurate drawing though. They just want to see if you get the shapes right, and yeah, they just want to see mainly if you get the shape right. And also, for a fact, most questions will not ask you to draw until 2 pi. Most of them would stop at pi or pi over 2. So be sure, I mean, it's not that I don't want you to memorize the entire thing. It's just that, just make sure to, know your graphs until pi and pi over 2, the shapes of them. Okay? All right. So, and finally we have cot tangent x graph. Okay. So this one's a bit of the anomaly here. It's like a bit of the weird one here, but it's still doable. Okay, all you can do, just think of cot tangent graph like this. You're just going to take this line over here and connect it with the below line here. Okay, and what I mean is, okay, so here's the tangent x graph, and the shape would simply reflect about a middle axis here. Okay, and you would get something like this. You'd get something like this, roughly something like this. Okay, and what's gonna happen is, okay, I told you about let me just write a note. The note is connecting all the lines. All the lines. And what we're going to do is, we're going to have this graph, this segment, this tail down here to connect with here. And how we're going to do that? So basically we're just going to, you know, like I said, like an invisible middle line here, we're just gonna have to reflect it about that. So this segment on top, this part will go here and the bottom part will go here. So you'd get something like this. Oh, this is really bad drawing, by the way. Yeah, something like that. And the same thing here. Okay, so the tip is you have to just draw a reflection mirror at the middle of each, tail over here. Okay, and the same thing for here. You're just going to draw an invisible, mirror here. And we're just going to reflect again. Same thing for the below graph. We're just going to draw a middle here and just connect it. Okay, so that's your cotangent graph. All you're doing is you're drawing a reflection line in the middle of each tails. Okay, so if you remember, for sine x and cos x, we're drawing a mirror on each peaks, am I right? However, for tangent graphs, we're drawing a line in the middle of each tail. Okay, so just for a tip, okay, maximum points, and I'm just gonna say this is for cosec graph and secant graphs. However, for cot graphs, we're gonna reflect about the middle of each tail. Okay, all right, so that's about trigonometric graphs. So it's really straightforward. Okay, and now we're gonna come to a few of the other basic graphs where they could actually ask you to draw. Okay, so over here there's going to be questions where they're going to ask you to draw the ln graph, ln x. And this thing is that it's just that it's quite simple to remember. I mean, ln x, when ln is 1, you get 0. So that's going to intersect at 0 here. Intersect the x-axis. And you're just going to get this curvy shape. Like I said, CIE does not really care how accurate your graph is, as long as you get the shape right and some of the intersection points right. Okay, so primarily for ln x, you will intersect at the x-axis at 1. Okay, and however, like I said, see, my graph here isn't very accurate, but ln of e gives you 1. Okay, so there's going to be a point where this graph is going to go quite constant. You can it's up to you. You can actually write at a point where it's 1. You can say here is e. It's not really necessary, but as long as you get the shape right, that's most important. So most importantly, just get your shape right and your intersection point right. Oh, sorry. Okay, all right, so that's ln x. And sometimes there could be questions maybe asking you ln x minus 2. Okay, so these kind of graphs, so you have to try to memorize your transformation. So if it's a minus inside, you're gonna plus 2 on the x-axis, where your graph would shift 2 units to the right, which it would be intersecting at 3. Okay, so that's some basic transformation you have to remember. Okay, and now we have our exponential graph. Okay, so for our exponential graph, EX, the basic graph drawing is like this, where when E is 0, it is equal to 1. Like over here, E0, you get 1 over here. So it comes all the way here, and it's climbing up because it's an exponential graph. It's increasing exponentially. Okay. Now there could be questions asking for e negative x. So when they give e negative x, all you have to do is switch the sides of the graph. So for EX, you have a climbing graph, it's climbing up. However, for E minus X, you're going to have a graph that's going down. And remember, the intersection point is still going to meet at 1 because E minus 0 is still going to give you 1. So the graph would technically be something like this. It's just a reflection again. Oh, I'm really bad with graphs, with drawing. Just give me some time on this. Okay, you should get something like that. I mean, forgive me for drawing. And like that. It's not the straightest graph, but it should. Oh my god, I'm so bad. Okay, yeah, it should be something like that. It's something like that, alright? So you're just going to reflect. If you see a negative here, just remember to reflect. Okay? And we have two of the most common graphs that we know, which are, the quadratic function graph and the cubic graph. Well, the quadratic graph applies the same for, the even powers, if you get what I mean. So what I mean is x2, x to the power 4, x to the power 6. There could be questions asking you about this. And like I said again, when you draw your graph, the most important thing is your shape. And maybe 1 or 2 points that are part of the graph you can actually label. And the same thing for over here. This is the graph for, odd powers like x3, x5, x6. We're more familiar with the cubic graph, but this applies the same for x5 and x7. So this is more of the odd powers, and this is the even powers. Okay, so that's some of the basic graphs that you're gonna have to know in order, to solve questions. So I'm gonna walk through a question or two with you, and we're gonna see how we can solve them. Okay. So, okay, this question doesn't really have much of a drawing. Okay, and by the way, just before I start, I just want to mention that I've got these worksheets, these topical worksheets from pastpaperpenguin.com, where they actually offer many topical questions, for your P1, your statistics, your P3, and your mechanics paper. Okay, so do check them out. So I'm using the resource from pastpaperpenguin.com. So, okay, let's have a look at this question where they're asking us to draw a graph. Okay, so they told us by sketching a suitable pair of graphs, show that the equation x to the power 5 is equal to 2 plus x has exactly one real root. So what this question is trying to tell us is they're telling us to draw two graphs on an xy plane, and we're going to have to show that they intersect at one point, which is the root. At one point where they call it root. Okay, so the thing is, you have two sides here, left hand side and the right hand side. So each of these are separate graphs, if you could think so. And these graphs are going to meet at one root. So the root of the equation, the root of those two equations is given by these two. I mean, this function over here. This equation here. This is where the root intersects. Okay? But to find that, we have to separate these two and draw two separate graphs to find the intersection point. So why don't we start first with y equal to x to the power 5? Let's just simply draft it here how it's going to look. So if you didn't know, okay, like in the earlier notes that I shared, so x5 is the family of the odd power graphs. So you're going to get this curvy S graph here. So what we're going to do is we're simply going to draw something like that. We're going to draw a graph like that, okay, and we're done. We're basically done. And if you actually like to, it's not wrong to add a few points maybe, but it's not really necessary. Okay, you can just leave it as it is. Okay, and now we're going to draw the 2 plus x graph, or x plus 2, which is easier in the y equal to mx plus c form. So we have a gradient that is 1. So normally when you get straight line graphs, a tip that I would do is just to find the x and y intercepts. So we know for sure that our y-intercept is 2. And if you want to find your x-intercept, just input the 0, input the 0 here, and you'd get x equal to minus 2. So our graph passes through -2 and 2, and just draw a straight line graph. Okay, sorry if my graph isn't that accurate, the drawing, but you should get something like this. And all you have to do is combine these two graphs. Okay, so I'm going to draw a big xy plane here. A big xy plane here. And by the way, these two are just for your reference, so you don't really have to write them here. And I suggest you not to, maybe better. I mean, like, you can, but it's better to erase them, you know. Okay, so x and y. So first thing, we're going to draw x to the power 5 graph. Okay. And it's good to label them, by the way. Just label them y equal to x to the power 5. And we're going to have another graph where we're going to, you know, it's best to use rulers in your exam, you know, to get a more accurate, you know, drawing. Okay. So just going to get it here. So what we're going to do is we're going to draw, you know, just for the sake of this, because I don't really have a ruler with me. So it would be more accurate, you know, if you use a ruler. And you're going to get something like this. I'm just going to adjust my graph. And you're going to have a point, once you draw your graph, I mean, don't forget label, y equal to 2 plus x. You're going to have a point where you're intersecting. And this is going to be a root. This is going to be a point where you're intersecting the two graphs. And that is given by this equation up here. That's the point. So, that's the x-axis. Okay, yep, okay. So you're going to get something like that. And another thing you have to remember is to, you know, draw an arrow and say one root where graphs intersect. You don't have to write too long. You can just write one root of, you know, I mean, you can write with just one root maybe, or you just have to show that it's intersecting at this point. Okay, so the key takeaway here is, you know, draw your graph, label them, and remember to label your root. Okay, so that's kind of it for graph drawing. You know, I'm just gonna go through maybe another. I'm just gonna mainly, you know, talk you through the graph drawings in this, you know, video, and you can try maybe to solve the below questions, because I actually made a video for these questions before. Or you know what? I'm actually just gonna solve it. It's okay. So over here we have xn plus 1 equal to 4x to the power 5 plus 2 or 5x to the power 4 minus 1. So they're telling you to show if this equation here converges with the equation up here, which is x to the power 5, you know, equal 2 plus x. So all you have to do is just rearrange the entire graph again, the equation again. 5 4 minus 1. Okay, so we're gonna bring this to the side. 5x to the power 4 minus 1 equals to 4x to the power 5 plus 2. 5x to the power 5 minus x equals to 4x to the power 5 plus 2. And when you can finally get x to the power 5, x plus 2. And, you know, just for safety concerns, I'm just going to write it as 2 plus x, because that's how they give in the question. And that's it, shown. Okay? And yeah, that's just 2 marks, by the way. So they're saying use the iterative formula with the initial value of x1 equal to 1.5 to calculate the root correct to 3 decimal places. Give each result of each iteration to 5 decimal places. So they're telling us to start with 1.5, and they said 5 decimal places, so I'm just gonna write the 4 extra zeros here. And what we have to do is we're gonna have to use this iterative formula that they gave here, because that's what they asked us to use, So you can just take a calculator, okay, and sub in the values. 1.5 5 plus 2, 5 to the power 1, 5 to the power 4 minus 1. And let me check. Okay, and for your first value, you should be getting 1.33162. And the next iteration, basically a quick tip, just insert the answer function button into each of your brackets where you're putting your x values, and just keep pressing the equal. So in the next one, I'm getting 1.27352. And in the next iteration, I'm getting 1.26724. And the next iteration, I'm getting 1.26717. And in the next iteration, I'm getting 1.26717. So I'm seeing it's getting quite constant. So we're just going to check out, values quickly. So to 3 decimal places, right? 3 decimal places. So this cannot be. Well, I can see here at 273, this 274, no, this is not the one. 2672, so 267, 267 and 267. So we can see that x4, x5, x6 all round off to 1.267 to 3 decimal places. Thus, x is equal to 1.267. Okay, so that's a pretty straightforward question. So next one, let's do another question. Over here, it's given to us by sketching a suitable pair of graphs again. Show that the equation ln of x is equal to 3x minus x squared. Okay, so this is an interesting one. So like I said, I hope you remember earlier, you can just separate these two and draw them separately. I'm just going to write in the quadratic way. Okay, so our first graph is ln of x. And from what I can remember, ln of x intersects at 1. So the graph is roughly going to be something like this. Very quickly. And this is a little bit of a tricky one here, where we get 3x minus x squared. So how are we going to do that? Okay. So a quick maybe method we can use is to just determine the roots of this quadratic. And okay, first thing first, it's a sad graph because the a here is a minus, so it's gonna go like this. And to find the intercepts, so negative x squared plus 3x equal to 0. So we're gonna get x minus x plus 3 equal to 0. So x equal to 0 and x equal to 3. So these two are gonna be our roots. So I can roughly draw here that my graph is going to be something like this. Yeah, it's going to be something like that. So the next thing is to just combine them again and again. So one real root again. So we're going to have to show they intersect at one point. Okay, so get the 1 here, maybe just draw it a bit far. Okay, okay, that's a nice graph. And our next, so we're just gonna label this again, and remember to draw the other one. Okay, so 0 and let's say 3 is here. So we're gonna draw this curve here. I'm sorry if my graph isn't correct, I'm just gonna adjust this. And 3. Okay, so if you can see, they intersect at one point here. So y is equal to 3x minus x squared and only one root. Okay, so that's pretty straightforward. Intersect at one point and see 2 graphs, and that's it. So over here they asked to verify by calculation that the root lies between 2 and 2.8. Okay, so in my first part of this iteration series, I actually talked about these questions. So all you're going to have to prove is that it's going to change from a positive to negative or negative to positive. And what I mean by that, okay, so you can choose, okay, so first off, you have our equation ln of x equals to 3x minus x squared. Okay, so to do these, all you have to do, I mean, it works either way, but for me personally, I believe that it's best to take the right hand side and bring it to the left hand side. So you get something like this. Okay, so first off, we're going to do for x equal to 2, so you're going to sub the 2 in here. You can also bring the ln here. However, I recommend it better to bring the right hand side to the left hand side, because most of the CIE answer schemes, they kind of more prefer that, and more of the workings done online is typically done when the right hand side is brought to the left hand side. So just try to stick to that. Okay, so we're going to input for x equal to 2, okay, ln 2 minus 3/2 plus 2 squared. So we're getting something about negative 1.307, and for x is equal to 2.8. Oh, by the way, don't forget to show that you're subbing the values in. Sorry. And ln 2.8 minus 3, 2.8 plus 2.8 squared. Okay, so for this one, 2.8 plus 2.8 squared, and over here I'm getting a positive 4.70. So if you can see, there's actually a sign change, negative, positive. So that shows that along the graph, let's say the curve, it's coming from a negative value and it's coming to a positive value. So there's going to be a sign change where it's negative and one here is positive. So that shows there's a root in between. So you can say sign change, and the function is continuous. Function is continuous, thus root lies between x equal to 2 and x equal to 2.8. Done. Okay, so use iterative formula they've given us to determine the root. Correct 2 decimal places, give each iteration to 4 decimal places. So if they didn't tell you which root to start with, you can actually choose either one. And for me personally, I prefer the lower root because I don't know, I just prefer it better. So we're gonna start at x1, which is 2.0000. So for our second iteration, just gonna sub in those values at 2.000 minus ln of 2.000. Oh, I'm getting an error. Okay. So for my first iteration, I'm getting 3.37. Okay, and my third iteration, I'm getting 2.4651. Fourth iteration, 2.5481. Fifth iteration, 2.5902. Sixth iteration, I don't see them coming to a specific value yet, so I'm still gonna go 26113, not yet. 2.6218, still not getting there. X8, 2.6271, I think they're getting closer. X9, 2.6297, and again 2.6310. I think we've done so many iterations. Let me just check back again. So the 2 decimal places, right? So this is going to be out. So we see that we have a lot of 2.6, so we're going to look at them more. 2.61, 2.62, so this can't be 2.6263. Okay, 2.63 we're getting here. 2.63 again, 2.6. Oh, so they're all rounding off to 2.63. So x8, x9, and x10 all round off to 2.63, thus x is equal to 2.63. Okay, sometimes don't get too anxious if you're getting too many iterations, because sometimes there are some formulas where it takes quite a number of times to get the right value. Okay, and maybe let's just do one last question here, where it's a trigonometric question. So this should be good. Okay, so they're asking us to graph y equals to secant x and y equals to, I'm just gonna write in the line form, has exactly one root. Okay, so first let's try to draw a secant graph. So if you guys can remember, okay, and by the way, they've given us a interval over here, a interval of 0 to 90 degrees, or 1 over 2 pi. Okay, so 1 over 2 pi. Alright, so if you could recall, okay, secant x is transformed from the cos graph. So cos graph, you're going to get something like this, where over here is going to be pi over 2, and it's going to be 3 over 2 pi. So like I said, the secant graph is basically the reflection. So about pi over 2, you just need to lift it up. That's it. That's secant x. And for our graph of negative 1 over 2x, you're just going to draw a straight line graph where our y-intercept will be 2. And to find our x-intercept, we're just going to sub 0 into y, where we're going to get x equal to 4. So 4. Our graph is going to look something like that. Okay, so I'm just going to put this to the side for a while. I'm going to draw the big plane. So they said for one root, I'm going to draw a big plane. Oh, okay, x and y, and I'm just gonna they're asking up to pi over 2, so I'm just gonna draw pi over 2 here. So our secant graph would be something like this. I mean, by the way, it starts at 1, so it should be something like this. And our another graph, so don't forget y equal to secant x, and our other graph starts at y-intercept of 2, so we're just going to draw it something like that. Okay, so like you can see, just going to label it plus 2, and this is only root. Okay, so that's the thing. Let me see if is there anything else. Okay, let me just calculate again. By 2, so 90 times shift pi t 1 over 2 pi, so 2. Okay, by the way, so you might be a little confused here by our x-axis is in radians, but however, one of our graphs is like kind of in digits. It's not even, it's like 4 over here. So how do I know where to stop? You might be thinking, oh, it could have ended here or something. But the tip is, when you're drawing a line graph, it's best to convert this, think of these angles in form of radians in numerical forms. So 1 over 2 pi would be 1.570. So at this point, when x is 1.57, and you actually sub it into your equation, minus 1 over 2, answer plus 2, you're getting 1.2, so which is slightly above the y-axis here. So that's why a line should end here. It shouldn't be touching the x-axis. So you can just convert this value into digit forms and sub it into here, where you can get your answer. So it's more easy to graph. So again, verify by calculation, root lies. So I'm just gonna take, okay, secant x equals to 2 minus 1 over 2x. So I'm just gonna move the right hand side to the left hand side. Secant x equal minus 2 plus 1 over 2x. So for x equal to 0.8, I am getting negative 0.165, and for no space, it's equal to 1. Secant 1 minus 2 plus 1 over 2, 1, I'm getting 0.351. So you see there's a sign change, negative, positive. So sign change and graph is continuous. It's continuous. Thus root lies between 0.8 and 1. Okay, and for final question C, use the iterative formula to determine the root correct at 2 decimal places. So we're going to use this one again. Okay, cos inverse to our 4 minus xn. So for our first one, we can, like I said, I prefer to use the lower root, which is 0.83. So when I input this value into the function, I'm getting 0.8957, 0.8707, 0.8774. We're getting closer, I guess. 0.8756. 8. Okay, I think I can see it. 8761. So 2 decimal places, right? So let me just try this a bit more clear. So over here, 2 decimal places, so we're getting 88, 88, and 88. So it rounds off to 0.88. So x4, x5, and x6 all round off to 0.8822 decimal places. Thus x is equal to 0.88. So yeah, so that's more about graph drawings. Okay, so what's most important is I hope you guys remember, the main graph drawings. Okay, so just try to remember how you can change the graph from sine x to cos x, and basic graph shapes. So that's all for this video, guys. I hope you understood, and I'll see you guys in the next video. All right, see you guys.